North Saskatchewan River.
I've heard the Mississippi River is too strong to swim in, and there are a lot of factors that really make that river dangerous.
It's true.
The American Midwest, a land famed for cornfields, rolling plains, and rustling forests. But beneath its quiet surface lies a world of forgotten fire, fractured bedrock, and ancient forces stirring once again. In 2025, geologists made discoveries across this seemingly calm region that shattered assumptions and revealed a hidden dynamism beneath the heartland of America. From deep seismic shifts beneath Illinois to ancient volcanic scars in Missouri, from mysterious underground chambers in Minnesota to magnetic anomalies beneath Michigan's Upper Peninsula, the Midwest is rewriting its geologic legacy, and fast. What secrets are buried beneath the bluffs of the Mississippi and the edge of the Great Lakes? Could the flatlands we know so well be disguising Earth's next big surprise? Prepare to uncover 10 shocking new revelations from 2025. Stories of fire, fracture, and forgotten catastrophes that continue to shape the Midwest beneath our feet. Seismic surprises beneath the New Madrid Fault. In early 2025, sensitive geophysical equipment detected a rapid sequence of micro-earthquakes along the infamous New Madrid seismic zone. But this time, scientists noticed something new. The depth, timing, and alignment of these tremors pointed to a deeper, partially reactivated fault system that had lain silent for over 1,000 years. Using 3D subsurface tomography and updated GPS deformation data, the USGS confirmed a previously unmapped vertical fault structure beneath southeast Missouri. This structure intersects the well-known lateral New Madrid faults, suggesting a more complex, intertwined fault network capable of delivering greater seismic force than previously modeled. The new fault runs at an oblique angle to the established system, indicating that older tectonic stress fields may still influence the crust. Preliminary simulations suggest that simultaneous rupture of the vertical and lateral faults could produce shaking strong enough to affect cities from Memphis to St. Louis. To validate this potential, scientists installed a denser array of seismometers, which picked up repeating low-frequency tremors, a sign of creeping motion and stress accumulation at depth. These slow earthquakes are often precursors to larger events and were previously undocumented in the Midwest. Geologists also trace the fault's alignment to ancient rift structures buried beneath thick sediment, implying that tectonic inheritance plays a bigger role in seismic risk than expected. Combined with new records of liquefaction in riverbanks and archaeological layers, this discovery has sparked a reevaluation of building codes and emergency preparedness across the region. Could this be the next source of a devastating Midwestern quake? The ground, it seems, remembers. Ancient volcanic core found beneath Missouri's Ozarks. While the Midwest is known for glacial landscapes and sedimentary rocks, a 2025 borehole sample from the Ozark Plateau changed that narrative dramatically. Drilling teams from the Missouri Geological Survey and several academic institutions exploring for potential geothermal reservoirs unexpectedly encountered a thick sequence of igneous rock beneath 1,500 meters of sediment. Analysis revealed this to be a remnant of a once active magma chamber, an ancient volcanic intrusion dating back over 1.2 billion years. Petrological studies confirmed the rock's origin as a high silica rhyolite, rich in rare earth elements, zircon, and trace metals, some of which are critical to modern electronics and green technologies. But what truly shocked researchers was the configuration of the magma body, a dome-like structure with internal layering, consistent with a large-scale volcanic system that may have produced explosive eruptions during the Proterozoic era. This discovery aligns with broader findings related to the Midcontinent rift system, suggesting that the Ozarks may have once been at the margins of significant tectonic stretching and magmatic activity. 3D gravity and magnetic models revealed concentric anomalies around the intrusion, supporting the theory that this ancient core represents a deeply eroded caldera structure, perhaps once as prominent as Yellowstone. Geologists estimate that this region experienced sustained magmatic uplift, intrusive activity, and eventual collapse, processes typical of supervolcanic events. Today, much of that drama is hidden beneath sedimentary layers and erosion, but the chemical fingerprint remains vivid. Thermochronology techniques also indicate that the region has seen multiple heating events, implying prolonged magmatic influence. The implications stretch beyond history. With renewed interest in domestic rare earth element sources, this ancient volcanic complex has drawn attention from economic geologists and mining firms. However, concerns about ecological disruption have slowed exploratory permitting. In tandem, geologists are now reevaluating seismic data from the surrounding region. Some subtle fault movements and minor tremors, previously dismissed as background noise, may in fact align with buried structural weaknesses associated with this ancient volcano. Could the Ozarks hold more such secrets beneath their quiet ridges? If one volcanic core remained undetected for 1 billion years, how many others lie dormant beneath the breadbasket of America? Magnetic mystery beneath Michigan's Upper Peninsula. In 2025, a low-altitude airborne survey conducted by the United States Geological Survey, USGS, over Michigan's Upper Peninsula yielded extraordinary data. Using magnetometers capable of detecting minute variations in Earth's magnetic field, scientists discovered a massive, perfectly circular magnetic anomaly more than 50 kilometers in diameter beneath Marquette County. Initial interpretations speculated the source was volcanic in origin, but further investigation uncovered something even more compelling: a fossilized magma chamber that dates back 1.1 billion years, tied to the long-dormant Midcontinent rift system. Drilling teams sent deep-core samplers into the heart of the anomaly. What they retrieved were thick layers of solidified basalt and magnetite-rich rock, layered in ways that suggested periodic lava injections over thousands of years. These layers, rich in iron and titanium, generated the powerful magnetic signature observed from the air. The configuration and depth of the intrusion bore the hallmarks of a collapsed magma reservoir, once active during the Proterozoic era when North America nearly split in two. Geophysical modeling revealed concentric ripple effects in the surrounding crust, suggesting the area experienced repeated thermal pulses and slow uplift. The structure's remarkable preservation offers scientists a rare look into the anatomy of a billion-year-old volcano. Intriguingly, surrounding fault lines, long thought inactive, displayed minor stress redistributions in recent GPS readings, prompting debate about the lasting geodynamic influence of such fossil structures. The implications aren't just scientific. The anomaly has attracted attention from mining companies for its potential as a strategic metal reserve. Samples return trace amounts of nickel, copper, and rare earth elements, resources increasingly vital for renewable energy technologies. Environmental groups, however, warn of the risk of disturbing such a unique and historically significant site. This finding has also reignited academic interest in the full extent of the Midcontinent rift's influence. If such a sizable volcanic remnant lies beneath Michigan, it raises questions about other similarly buried features under Lake Superior or into neighboring Minnesota and Wisconsin. Could these ancient magma bodies still exert subtle influence on today's crustal dynamics? Or are they merely fossil echoes of an Earth far different than the one we know today? Iowa's buried crater, the Manson impact structure revisited. Nestled beneath the farmlands of north-central Iowa lies one of North America's most intriguing hidden scars, the Manson impact structure. Long believed to be a well-understood relic of a 74-million-year-old asteroid impact, this ancient crater received renewed attention in 2025 when a consortium of geophysicists and paleogeologists initiated a deep resonance seismic imaging campaign paired with high-resolution subsurface tomography. The results were astonishing. The buried crater was not only wider than previously estimated, expanding the known diameter from 35 kilometers to nearly 42 kilometers, but also far more structurally complex. Advanced models revealed a multi-ring crater system similar to those seen on the Moon or Mars. Beneath layers of sediment, geologists found radial faults, concentric ring fractures, and an uplifted central dome, all signatures of high-energy, high-velocity impacts. One key revelation came from core samples taken from the central uplift. These showed evidence of shock metamorphosed quartz and high-pressure minerals like coesite and stishovite, indicators of a colossal pressure wave consistent with an impactor at least 2 kilometers wide. The discovery reignited debate over whether this impact event contributed to pre-KPG environmental stress that later culminated in mass extinction. More fascinating still, sediment analysis revealed disruptions to hydrological patterns across what is now Iowa and parts of Minnesota and Nebraska. Aquifer channels appear to have been rerouted, and fossil records show a spike in waterborne diatoms above the impact layer, suggesting the crater may have briefly hosted a massive impact-generated lake. Public interest soared as the team used virtual reconstruction to animate the moment of impact, displaying shock waves rippling through ancient seas, ejecta arcing into the atmosphere, and a mushroom cloud that would have altered local climates for years. Today, the impact site is completely buried under glacial and post-glacial deposits, yet its legacy influences everything from aquifer patterns to local magnetic anomalies. Several schools and museums in Iowa have since proposed turning the Manson structure into an educational geoscience corridor, linking science, tourism, and conservation. Could other buried craters lie hidden in the Midwest's vast plains? And could subtle features in the landscape, odd drainage paths, or seismic echoes hint at more cosmic collisions waiting to be discovered? Wisconsin's underground waterways discovered. In a discovery that redefines the hydrology of the American Midwest, scientists in 2025 uncovered an extensive system of underground waterways beneath Wisconsin's driftless area, an ancient landscape untouched by the last glaciation. This region, long studied for its karst topography and mysterious sinkholes, proved to harbor one of the most intricate networks of subterranean aquifers, limestone caves, and mineral-lined passageways ever documented in North America. The breakthrough came through the application of muon tomography, a novel imaging technique that uses cosmic ray particles to visualize density variations beneath the Earth's surface. Over the course of several months, researchers from the Wisconsin Geological and Natural History Survey and a team of international collaborators mapped hollow corridors stretching for dozens of kilometers. Some were as wide as 15 meters, with roof heights exceeding 10 meters, creating cathedral-like chambers veiled in absolute darkness. What they found was astounding. Isolated underground lakes filled with mineral-saturated water, microbe-rich muds, and complex stalactite formations that hadn't seen light in thousands of years. Several of these reservoirs are geochemically unique, showing elevated levels of calcium, iron, and magnesium, and in some cases, unexpected traces of sulfur bacteria typically found near hydrothermal vents. These hidden waters are believed to be remnants of massive meltwater channels formed during the Pleistocene epoch. As glaciers advanced and retreated, the region's porous limestone allowed subglacial flows to carve winding channels through the bedrock. Over time, these channels sealed off from the surface, becoming subterranean preserves of ancient water chemistry and biology. Exploration robots, designed to withstand extreme conditions, have already collected microbial samples from isolated chambers. Early results suggest the presence of extremophiles, organisms that thrive in high-pressure, low-oxygen environments. Their DNA may hold secrets relevant to early Earth conditions, or even extraterrestrial life. The find has scientific, environmental, and cultural implications. New maps of the aquifers will influence future groundwater protection policies, especially as concerns about nitrate contamination and water scarcity grow. Conservationists are calling for the region to be granted special geologic heritage status, while local indigenous groups have expressed interest in incorporating these sacred underground features into traditional narratives. What else might lie hidden in the depths of Wisconsin's untouched earth? Could these passages connect with older, even deeper geothermal reservoirs? And will these findings change how we manage and value the water beneath our feet? Sudden uplift detected beneath Minneapolis. In one of the most surprising geological revelations of 2025, scientists detected an unexplained ground uplift in the Minneapolis-St. Paul metropolitan area. Using INSAR, interferometric synthetic aperture radar, satellite data, researchers observed a gradual but persistent vertical rise of approximately 2.7 to 3.1 centimeters in select neighborhoods over an 8-month period. The pattern was centered on the western outskirts of Minneapolis, extending in a lobe-like shape toward the Mississippi River. At first, many assumed the uplift was tied to seasonal groundwater recharge or infrastructure-related subsidence reversal. But subsequent ground-based GPS monitoring and gravity measurements suggested something far more unusual. The uplift was accompanied by minor local gravity anomalies, indicating a possible increase in subsurface mass or changes in subsurface fluid distribution. Geologists and geophysicists from the University of Minnesota began modeling potential causes. One leading hypothesis is that the uplift is the result of isostatic rebound, a gradual rising of the Earth's crust after the weight of ancient glaciers was removed thousands of years ago. However, the rate and localized nature of this uplift doesn't fully match known rebound patterns elsewhere in the Midwest. Another theory proposes that crustal fluids, possibly deep-sourced brines or gases, are migrating upward along buried fault zones or fractures beneath the metro area. If so, This may indicate slow tectonic or magmatic activity at a level far deeper than previously considered active in the region. Archival records were scoured for historical clues. Interestingly, there were 19th century reports of minor tremors and odd ground swelling events in the same general vicinity, long dismissed as anecdotal. Combined with faint seismic tremors recorded on recently deployed instruments, the case for a tectonic explanation is gaining traction. Urban planners and civil engineers have also taken note. While the uplift is not enough to cause structural damage yet, it could complicate drainage systems, foundations, and underground utilities in affected areas. Monitoring has since been intensified, with a dense network of GPS stations and tilt meters installed around the Twin Cities. Could Minneapolis be sitting atop an ancient, slow-moving tectonic block? Might this uplift herald broader crustal movement in the northern Midwest? Or is it a localized anomaly without wider significance? As scientists investigate further, the Twin Cities now find themselves at the center of one of the region's most quietly intriguing mysteries. Carbon dioxide leaks in Illinois' volcanic past. In 2025, scientists from the Illinois State Geological Survey detected faint but measurable carbon dioxide, CO2, emissions in the Shawnee Hills region of southern Illinois, an area long considered tectonically and volcanically dormant. Initial surveys were intended to investigate minor ground deformation and unusual tree die-offs, but airborne gas spectrometry revealed a different story. CO2 was seeping through discrete fractures in the bedrock, particularly around old fault zones and deeply buried volcanic intrusions. The team conducted soil gas analyses and installed continuous monitoring stations across several suspected hotspots. Results showed elevated concentrations of mantle-derived CO2, gas with isotopic signatures distinct from surface sources like decaying plant matter or industrial emissions. These gases appear to be slowly rising through ancient volcanic conduits that date back over 1.4 billion years, tied to Proterozoic tectonic and magmatic activity related to the rifting of the North American continent. The presence of these gases challenges long-standing assumptions about the deep crustal inactivity of the region. Some geophysicists now believe that slow degassing may be part of a broader pattern of crustal evolution in southern Illinois, possibly involving ongoing cooling and fluid migration from the Earth's mantle. Moreover, these emissions tend to concentrate in low-lying areas and sinkholes, posing a potential but little-known health hazard to both wildlife and rural residents. What makes the discovery even more remarkable is its proximity to the failed New Madrid rift arm, a structure related to the ancient Midcontinent rift system. Some researchers posit that these long inactive faults and dikes may still act as conduits for mantle volatiles, serving as fossil chimneys through which CO2 can escape. Environmental agencies have begun working with local governments to issue guidance on safe agricultural practices and land use planning in areas with elevated soil gas levels. Emergency drills and gas detection training are now being conducted in communities such as Harrisburg and Vienna. In addition to the safety implications, this discovery opens new doors for understanding Earth's deep carbon cycle. Could Illinois become a model for monitoring long-term volcanic degassing in so-called stable continental interiors? Could this be a key to unlocking hidden geothermal potential across the Midwest? For now, the answer lies in careful observation and in heeding the quiet breath of an ancient Earth still whispering beneath the soil. buried lava tubes found beneath Indiana farmland. LiDAR imaging of central Indiana farmland, initially for drainage planning, uncovered subtle subsidence patterns that aligned with ancient lava tubes. These narrow, linear features stretched for dozens of kilometers beneath the surface. Core drilling confirmed the tubes were filled with solidified basalt flows, proof that Indiana, too, once hosted lava fields tied to the Proterozoic rift. Some researchers speculate that these tubes may one day be repurposed for carbon storage or geothermal energy development. Fossilized hydrothermal vent system in Ohio. In early 2025, paleontologists excavating Silurian age rock in eastern Ohio found signs of a fossilized hydrothermal vent system, complete with tube worm fossils and metal-rich sediments. The site, once a shallow seafloor near volcanic ridges, preserved a moment of primordial life clinging to seafloor vents. Its discovery marks the first of its kind in the region and offers a rare look at life's ancient relationship with volcanism. The hidden rift that failed, Midcontinent rift, Reexamined. Finally, the centerpiece of 2025's discoveries was a reassessment of the Midcontinent rift itself. New seismic data and gravity mapping revealed deep structures 200 kilometers down, indicating the rift came closer to splitting the continent than anyone realized. This failure left behind massive igneous provinces, ancient faults, and crustal scars now being reinterpreted as latent zones of weakness. As pressure and stress build in Earth's crust, the question arises, could this failed rift someday awaken? What lies beneath the Midwest? What do you think lies beneath the surface of the Midwest? Have you ever felt a tremor, seen a sinkhole, or wondered about what's really happening underground? Share your thoughts and theories in the comments. We're reading everything. If these revelations shook your understanding of the Midwest, imagine what's coming next. Hit subscribe and turn on notifications, because the Earth isn't done revealing its secrets, and neither are we.